Hi everyone. Today we're going to be talking about comparing two statements, comparing the truth value of two statements against one another, and we're going to be talking about the different names that we have for different statements. So the four names we're going to be talking about, and the four different comparisons we have are they are logical equivalence, contradiction, consistency, and inconsistency. So my personal favorite is logical equivalence. That's the one we're going to be talking about first. So the first example is if P then Q. So we're going to draw our little arrow or horseshoe, and we're going to put if P then Q. Now from the truth values we put earlier, you should know that we have true, true, false, false, and true, false, true, false. So as a result, we get true right here because they're both true. Since we get a true and a false right here, we get a false. When the antecedent on the left side is false, then we always get a true. So we have right here. I want you to take special notice at the truth value of the conditional. And as you can see, the truth value of the conditional is true, false, true, true. Now, if P then Q is logically equivalent to something else in logic, which is not, here, I'll move this a little bit to the right. So it's not P or Q. These two are called logically equivalent. And the reason they're logically equivalent is because they have the exact same truth value. Not P or Q has the truth values true, false, true, true. So I'll show you in a second. So as you can see, P has the truth values true, false, true, true. And so since it's being negated, the negation takes priority over it. So if P has true, false, true, true, if P has true, true, false, false, then the negation is going to get false, false, true, true. And then we come here with Q, and we just copy the truth values. True, false, true, false. And so now we construct the truth value of the OR operator for its disjuncts. So the OR operator again is true when one of the disjuncts is true. So right here Q is true, so we give it a truth value of true. Right here they're both false, so we give it a truth value of false. Right here the negation is true, so we give it a truth value of true. And right here again the negation is true, so we give it a truth value of true. And as you can see right here, they have the exact same truth values. True, false, true, 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 false, true, true. So what that means is that they're logically equivalent to one another. The next statement I want to show you is contradiction. So two statements are contradictions when they have complete opposite truth values. So for this, I'll just use P and Q and not P and Q. So whenever we negate something, we will get opposite truth values. Whenever we negate an operator, we get opposite truth values. Well, propositions too, but for our purposes, we're going to be using the truth values of the operator. So we'll put here P and Q and not P and Q. So right here for P and Q, we get true, true, false, false, and true, false, true, false. So remember the conjunction operator is only true when they're both true, which is only in the first line, and for the rest, since they're not both true in any other line, we get false, false, and false. Now, since we're negating not P and Q, we should get opposite truth values. So we get false, true, true, true. So what you can see right here is they have opposite truth values on every single line. So right here we get a true, right here we have a false, right here we have a true, right here we have a false, right here we have a false, right here we have a true, right here we have a true, and right here we have a false. So they have the exact opposite truth values. So in comparing these statements, they're a contradiction, they're contradictory. So let's delete this fill, and the next example I want to show you of is two statements that are consistent. So consistent means that that both statements are true at least once on the same line. So let's just do P or Q and not, or just P or Q and P and Q. So right here, true, true, false, false, true, false, true, false, true, true, false, false, true, false, true, false. Okay, so for the OR truth value, the OR is true, the OR operator is true whenever one of its disjuncts is true. In the first line, we get true. Second line, we get true. Third line, we get true. Fourth line, we get false. The conjunction is only true when both of the conjuncts are true. First line, we get true. Second line, we get false. Third line, we get false. Fourth line, we get false. But as you can see right here, I'll just make this red. So you can see right here in line 1, or at least I guess on line 3 I should say. On line 3 they have the same truth value, and so these statements are consistent. And so the last example I want to show you when comparing statements is one of inconsistency. And so what inconsistent means is that the arguments, that the two statements are not true on the same line. So for this, I'll use P and Q, and I'll use not P. I'll draw my little arrow, equal sign, open question mark, dash, dash, greater than sign, close question mark, and then Q, and close parenthesis. So P and Q and not P or Q. So I've already showed how to get the truth value for P and Q a couple times, and I already have it memorized, so I'm just going to write it down, which is true, false, false, false. P and Q is always going to have this truth value. P and Q is always going to have true, false, false, false. So I'm just going to write that down there. I also know the truth value for the material conditional, normally, when it's not negated. Truth value for a normal material conditional is true, false, true, true. So if it's being negated, we're going to get opposite truth values, which are false, true, false, false. And so as you can see right here, both statements are never true on the same line. P and Q is true on line 3, and not P then Q is not. Not P then Q is true on line 4, and P and Q is not. And although they both share the same truth values on lines 5 and 6, which are false, for them to be consistent, they both need to be true on the same line, which they're not. So these are a few ways of comparing statements, and I'll see you guys in the next video.